Hypothesis testing of the population proportion. Hypothesis testing is a technique used in statistics to test whether a claim that is made is consistent with the data obtained. If someone says that 40% of the cars in Ireland are black, common sense tells us that this is wrong. But how do we prove it? We need to obtain evidence from a sample. For example, we could conduct a survey of a large number of cars and suppose that we find that 32% of cars are black. This would suggest that the claim is wrong. But does it prove it? Or has a very unlikely event just occurred, with the claim still being correct? We need a systematic way of deciding whether or not to reject the claim. This is where hypothesis testing comes in. The method of hypothesis testing is very precise, and the steps outlined below must be followed. These steps are outlined as they apply to the types of hypothesis testing on our course. At a more advanced level, other options and steps exist. Step 1. State the null hypothesis H0. The null hypothesis H0 is that there is nothing wrong, null equals nothing, with the claim. For example, if the claim is that the population proportion is 0.4, then we write H0, P equals 0.4. The way hypothesis testing works, unless we have sufficiently convincing evidence to the contrary, we do not reject the null hypothesis, i.e., we do not challenge the claim. It is important to note that this is not the same as saying that we accept the claim. This is similar to criminal court cases, where a defendant may be found not guilty. This is not the same as saying that he or she is innocent, merely that the charge has not been proved. Step 2. Identify the alternative hypothesis, H1. The alternative hypothesis, H1, also written as HA, is the hypothesis we accept if we have enough evidence to reject the null hypothesis. On our course, the alternative hypothesis will always be that the null hypothesis is wrong. For example, H0 is P equals 0.4, then H1 is P does not equal 0.4. On other courses, there are different possible forms of the alternative hypothesis. For example, that the claim is overstated or understated rather than just being wrong. Step 3. Obtain the sample statistics. Identify the sample statistic, i.e. the sample proportion p hat. One important aspect of hypothesis testing is deciding the level of significance, i.e. how unusual a result must be before we claim that it is wrong. A 5% level of significance means that if the result lies among 5% of the most unlikely results, we will reject the null hypothesis, and therefore accept the alternative hypothesis. Otherwise, we do not reject the null hypothesis. In this section, we look only at a special case of hypothesis testing, i.e. where we are testing a claim about the population proportion, the level of significance is 5%, we are allowed to use the margin of error approximation E equals 1 over root n for the margin of error of the distribution of the sample proportions for samples of size n. As we know from section 40.1, approximately 95% of the sample proportions will lie within E equals 1 over root n of the population proportion, i.e. within the interval P minus E, P plus E. Hence, 5% of the sample proportions will lie outside this interval. We can use this knowledge to make a decision about whether or not to reject the null hypothesis. Part 4. Make a decision. Having calculated E, P minus E, and P plus E, we can now make our decision. If P hat is greater or equal to P minus E, and less or equal to P plus E, i.e. the sample proportion, so P hat, the sample proportion, lies within the margin of error of the population proportion, according to the null hypothesis, then we do not reject the null hypothesis, H0. In this case, we can say that the result is not significant. Or, if p hat is less than p minus e, or if p hat is greater than p plus e, then we reject the null hypothesis, H0, and we accept the alternative hypothesis, H1. In this case, we can say that the result is significant. The region of values of p hat for which we reject the null hypothesis is called a critical region, and p minus e and p plus e are called critical values. So we see here we have our curve, our normal curve. P lies in the center. We have this point here being p minus e, and this point here being p plus e. So these points are known as the critical regions. So we see that the area underneath the curve is 95%, and each of the tails are 2.5%. And altogether that makes up 100%. This basis upon which we decide our conclusion is called the decision rule. If the value of p hat is very close to either of the critical values, then we tend not to reject the null hypothesis. This is similar to a court case and the idea of beyond reasonable doubt. Example: an engineering company states in its literature that only 20% of its products experience a problem within the first 5 years of use. To investigate this claim, you sample 400 of their products and find 98 of them have experienced a problem within the first 5 years of use. Part 1. What is the hypothesis? The hypothesis is assumed to be the null hypothesis. The hypothesis is that the company's claim is true, i.e. H0 is P equals 20%, which is 0.2. So you got the 20% from the question. Part 2. On what basis will you reject or not reject the hypothesis? We will reject the hypothesis if the sample proportion lies outside the margin of error of the stated proportion. If it does not lie outside the margin of error, we will not reject the hypothesis. Part 3. Calculate the margin of error using the margin of error approximation. To calculate the margin of error, we have E equals 1 over root 400, because our formula is E equals 1 over root n, and there are 400 products sampled. 1 over root 400 gives us 1 over 20, which is 0.05, which is 5%. So the margin of error is 5%. Part 4. Calculate the sample proportion of failures within the first 5 years. The sample proportion of failures is p hat, which is 98 divided by 400, which is 0.245, which is 24.5%. So the 98 came from here, where we found that 98 of them had experienced a problem within the first 5 years of use, and the 400 came from here. There was 400 in the sample. So 98 divided by 400 gave us p hat. Part 5. Can you conclude that the company's claim is false and give a reason? We will reject the hypothesis if p hat lies outside the interval from 20% minus 5%, which is 15%, to 20% plus 5%, which is 25%. So the 5% was the margin of error. As p hat is 24.5%, we got that in part 4, and it does not lie outside this interval, so it lies in between 15 and 25, we cannot reject the hypothesis H0. Thus, we have not got enough evidence to dispute the company's claim. So if we had worked out p hat to be less than 15% or greater than 25%, which would lie outside the interval, then we would have been able to reject the hypothesis H0. And therefore we would have accepted the alternative hypothesis.